Finding the input impedance of a given op-amp circuit. How do we calculate here? For that, we just make use of the basic methods what we learnt in network analysis, nothing else. Generally, in networks, right, if a circuit is given, then how do we find the equivalent resistance? Suppose I have a network which has with the two ports, find the equivalent resistance. Then what we do here? Simply the in method 1, simplification of the circuit. First one means two resistors are parallel, their equivalent is R1 R2 R1 plus R2, we write it, and two resistors are in series, then R1 plus R2, like that we can write, and we make use of star delta conversions and some techniques to simplify the circuit, and finally we come up with a single resistor. Okay, that's what is method 1, where there are no dependent or independent sources in the circuit that time. And in method 2, what we do? We take the same network and connect a source Vx and let the current coming out of it be Ix. Then we try to derive what is Vx by Ix. R equivalent is equal to Vx by Ix. That's it. Okay, you may connect some 5 volts or 10 volts or 1 volt like that. So most of the times what we do, we connect 1 volt source and we find 1 volt and let this current be I, then R equivalent is equal to Vx by Ix, that is 1 by I. So means if you know the current that is coming or entering into the terminal, then we can take the reciprocal of it and that gives the equivalent resistance. This is one method and it need not be 1 volt. You can connect, if you connect 5 volts, then you can calculate the current accordingly. This is a general formula. Okay. And you can use current sources also. You can use 1 ampere current source, so that R equivalent will be the voltage across the two terminals. Okay, that gives the equivalent because Vx is V and Ix is 1 ampere. So R equivalent is equal to V ohms. We can write that way also. Okay, so instead of all these things, what we do, right? These are the different methods, right? You have done a lot of exercise on this. You might have done in networks. So here I'm just making use of this technique as far as op-amps are concerned. Okay, see, just as an example, I'm writing here one simple circuit without op-amps. I'm writing first 2 ohms, 4 ohms, 2 ohms, 2 ohms. We are well aware what is the equivalent resistance here. Here, what we can write, these two are in series. Method 1, according to that, it is 4 ohms and this is 4 ohms. So 4 ohm parallel, it is again 2 ohms. Further 2 ohms plus 2 ohms, they are in series. So R equivalent is 2 plus 2, it is 4 ohms. We are well aware of it. Or otherwise, I told you arbitrary source means 1 volt source and let this current be I. Okay, then just what is the voltage at this point, if you see so? Okay, it is no doubt 0.5 volts. Then what is I? I is equal to 1 minus 0.5 by 2 ohms. Then it is 1 by 4 amperes. Then R equivalent is equal to Vx by Ix. Vx is 1. The reciprocal of the current I said. Anyway, it is 4 ohms. It's as simple as that. And we can even connect a current source and measure it, doesn't matter, or it need not be 1 volt, any arbitrary voltage. Okay, I'm just taking the same circuit. Let me connect some 5 volts source and let this current be Ix. Then what is the voltage at this point? It is 2.5 volt. We know this. It's a simple circuit, right? For saving my time. Just recollecting the points, nothing else behind it. So Ix is equal to 5 minus 2.5 by 2. It is 1.25 ampere. Then R equivalent is equal to Vx by Ix. That is equal to 5 by 1.25. It is 4 ohms. That's it. So here our circuit does not change. So this is not changing in all the cases, right? But every time what you are writing, the equivalent resistance means, right? If you see here, you are able to directly simplify the circuit in first method. In second method, what we did, we connected some arbitrary voltage source and the voltage source by the current that is leaving the source. That gives us the resistance. Ultimately, this is not changing and the value should not change. Whether you connect voltage source or current source or 1 ampere current source or 1 volt voltage source or 5 volts or 10 volts voltage source, doesn't matter. Anyway, here in analog, what we do is this method, right? Arbitrary voltage source, some source voltage by the current coming out of the source. Every time I try to derive this, that method. Okay. See, let us start with simple inverting Opamp circuit. R1, R2. I want to see the resistance looking into this. Let me write Ra. Then some source is connected here, P input, and the current is II. Let me write. Okay. Then I need to derive what is Vi by II. That's it. So due to virtual short, here it is 0 volts. So what is II? It is Vi minus 0 by R2. Then Ri or R equivalent, it is equal to Vx by Ix. Instead of Vx, what I have? Vi, and instead of Ix, II. Its value is simply R2. It is as simple as that. It's not like R1 parallel with R2 or R1 plus R2, etc. The II may go like this, doesn't matter. Okay, but what I am deriving, V input by II, source voltage by the current leaving the source. That's it. What is the value? It is R2. So the resistance looking from the source is R2. Ri is equal to R2 in this example. Suppose I have a circuit like this. What do we do? Procedure is same. Okay. So let me take this current as II, and due to virtual short, it is 0 volts. It is 0 volts. It is 0 volts. Is there any current possible here? It is simply 0. I need not worry about R3. And what about II? II is equal to Vi minus 0 by R2, implies Ri is equal to Vi by II. It is R2 only. Both circuits will give us the same value of input impedance. Then see this non-inverting Opamp circuit. V input. Okay. So what about the current that is flowing? Just to find Ri. in the circuit. What about II, friends? II is 0. The current entering into either inverting or non-inverting terminal of op-amp is always 0 due to infinite input impedance. So Ri is equal to Vi by Ii, that is Vi by 0, its value is infinite. That's it. No need to worry about R1, R2, etc. Now let me take this. And here it is V. Let me take the current coming from the source is equal to II. Anything we can write DC or AC source, doesn't matter. And what is the direction of I? Whatever II comes, entire II has to go like this only, where II is equal to V input by R3 plus R4. So Ri is equal to Vi by II. It is R3 plus R4. That's it. It's as simple as that. Just simply I'm deriving what is Vi by II, nothing else. Okay. Now let us see some problems. Okay. See this. The input resistance Ri of the amplifier circuit shown in figure is. They are asking to find the resistance looking into this particular terminal. Okay. So there I am connecting the source. We input, it is 30K, 10K. Then the current going from the source, going out of the source is II. So what is the value? 10K only. Okay. So we are well aware of it. Due to virtual short, it is 0 volts. II is equal to Vi minus 0 by 10K. Ri is Vi by II. It is 10 kilo ohms. A very, very simple question. Consider the inverting amplifier using an ideal operational amplifier shown in figure. The designer wishes to realize the input resistance seen by the small signal source to be as large as possible. Okay. While keeping the voltage gain between minus 10 and minus 25. The upper limit of R1 is 1 mega ohm. The value of Ri should be. Okay. As far as the circuit is concerned, what is Ri, friends? It is simply R2. Okay. So what is the value of Ri should be maximum? Means what is the maximum value of R2 they are asking. Okay. And R1 is given as 1 mega ohm. Okay, R1 is given and the gain range is given, and to have high value of input, what should be the value, right? What is the value of maximum value of Ri they are asking? Means maximum value of R2 we need to find. Okay, so first of all, what is the gain here in this circuit? The gain is equal to minus R1 by R2. We are well aware. Okay, so and gain R1 is given 1 mega by R2. If gain is minus 10, then it is minus 1 mega by R2, implies R2 is equal to 1 mega by 10, 100 kilo ohms. Okay, and similarly if A is equal to minus 25, which is equal to minus 1 mega by R2, implies R2 is equal to 1 mega by 25, it is 40 kilo ohms. Which value to be taken? Okay, definitely maximum value of Ri means this is of course I can write Ri This is Ri and this is Ri. Which is Ri maximum and Ri, which is Ri minimum? Definitely it is Ri maximum. Okay, this is Ri minimum. You see how it is. Minus plus. See here it is 1 mega ohm and it is variable input. So gain magnitude I am taking, it is minus 1 mega by R2. What is the maximum gain? When Ri is minimum, okay, R2 and Ri are one and the same. When Ri is maximum, that time the gain is minimum. R2 is maximum, that time the gain is minimum. Gain magnitude I am taking. Okay. So, which is equal to, okay, which is equal to how much it is? It's minus 10 they give. So that Ri maximum is, okay, Ri maximum I said 100k. So you are getting that. Magnitude I am writing. Okay, minimum gain magnitude. Next, maximum you can see means by reducing Ri in the denominator, right? It is fixed. By reducing Ri to what level? Up to 40k. You can see the maximum gain. Maximum gain magnitude only I am taking 1 mega by R2 or Ri minimum. 1 mega by 40k, it gives us 25. You can vary this input resistance from 100k to starting with a maximum of 100k to coming down to a minimum of 40k. Then the gain magnitude will change from minimum of 10 to a maximum of 25. Okay, this is the idea here. So our answer should be this one. Okay, the designer wishes to realize the input resistance seen by the small signal source to be as much large as possible while keeping the voltage gain between. So the upper limit of R1 should be upper limit of R, the value of Ri should be 100. Okay. A differential amplifier is constructed using an ideal op-amp as shown in the adjoining figure. The value of R1 and R2 are 47k and 470k respectively. The input impedance seen looking into the terminals V1 and V2 with respect to ground respectively are, okay. See, it is also a very simple question. While studying with respect to V1, we will set V2 0. Okay, so what do we get here? Minus plus R2, R1, V1. Here V2 is 0. Again it is R1, R2. We need not bother about it. Even this, their equivalent resistance is R1, R2 by R1 plus R2. But no current flows into this terminal and we can remove this. And this is equivalent to, this is equivalent to this circuit. R2, R1, V1. So what is Ri1? What is the resistance looking into this terminal? It is just nothing but R1 in this example, this resistor. What is its value? It is 47 kilo ohms. That's it. Okay. Similarly, the second one. While studying the effect of V2, we will set V1 0. This is how the current will be flowing. So Ri2, it is R1 plus R2. R1 is 47K plus R2 470K. It is 715, 517 kilo ohms. It's as simple as that. So option C is correct. See this question. The input resistance of the circuit shown in figure, assuming an ideal op-amp, is. See, let me take this current as II. Okay, this is the node, and here two currents are possible. One current is going like this. Let me take this current as I1 and this current as I2. So II is equal to I1 plus I2. Ri is equal to V input by II. Okay, so we need to derive what is V input by II. First of all, what is I1? Due to virtual short, it is 0 volts. I1 is equal to V in minus 0 by R. That is V input by R. Keep it aside. And I2. I2 is equal to V in minus V output by 2R. But we do not know what is V output. How to find V output? Okay, you take this node equation, node A, KCL at node A. Then 0 minus V input by R plus 0 minus V output by 3R implies V output is equal to minus 3 times V input. Then which implies I2 is equal to V in minus V output means minus 3 times V input by 2R, that is 2 times V input by R. Okay, I1, I2 we have got. Then what about I? I is equal to II is equal to I1 plus I2, that is V input by R plus 2 V input by R. It is 3 times V input by R. Then Ri is equal to V input by II. It is nothing but R by 3. That's it. Simply what I'm doing, I'm deriving what is V input by II, nothing else. So our answer, option A, is correct. Okay. Next, see this question. The input resistance of the circuit shown in the figure, assuming ideal op-amp, is. Okay, here also this is II. Ri is equal to Vs by II. Again, II is equal to, let me take two currents. This current is, one current goes like this. It is I1 and another current goes like this. Let this current be I2. Okay. So what is I1 here? Same procedure. I1 is equal to Vs by R4 plus R3. We can write. And I2. I2 is equal to, it looks like Vs minus V output by R2 plus R1. Alright, that's one way. And what about V output? You know this circuit. In this circuit, how to find V output? We are well aware. We can write that. That is another one way of writing. Instead of that, I would like to simplify the things. Right? Instead of just writing like what we did in the previous problem, here what I do is, let me take this voltage as V plus. What is V plus, friends? V plus is equal to Vs into R3 by R4 plus R3. which is equal to V minus. So voltage at the non-inverting terminal is equal to voltage at the inverting terminal. Then I write I2. What is I2? Vs minus V minus by R2. I can write. So I2 is equal to Vs minus V minus by R2. It is Vs minus. What is V minus? It is Vs into R3 by R4 plus R3 whole thing divided by R2. Okay. So how much do we get? It is Vs into R4 by R3 plus R4 multiplied with R2. Okay. I2 also has come. I1 and I2 are known. Then we can write the value of II. Then II is equal to I1 plus I2. I1 is Vs by R3 plus R4 plus I2 is Vs into R4 by R3 plus R4 into R2. Then if I take Vs by R3 plus R4 common, it is 1 plus R4 by R2. That is finally what we can write is R2 into R2 plus R4 by R3 plus R4 into Vs, that is our II. So Ri is equal to Vs by II. What is its value? It is sorry, here is a mistake. R2 should come in the denominator. No? Yes. Okay. Then it is equal to R2 into R3 plus R4 by R2 plus R4. Absolutely. Right. Right. If you take it, if all are equal, then your answer will be R2. If all the rests are equal, R1 is equal to R2 is equal to R3 is equal to R4 is equal to R, then your answer will be R. Okay. Let it be. Right. You are getting ohms only. Nothing to worry. So if you look at the options, R2 into R3 plus R4 by R2 plus R4. Option D is correct. Okay, that's it. The procedure remains the same. It's all about how to calculate I1, I2 in terms of Vs. Again, see this. The input resistance of the circuit shown in the figure, assuming ideal op-amp is. So let me take this current as II. Whatever the current that is leaving the source, the same current will be entering. This is again II. Okay, right. So V input by II is my answer. How to find this? You see, it is V plus and it is V minus. Here I am assuming a voltage Vx. What is Vx? Anyway, V minus is equal to V plus, so definitely Vx will be 0. Now let me take this loop. Let me take this as loop 1. Then KVL2 loop 1. What we get? Minus Vi plus II into R2 plus Vx plus II into R4 is equal to 0. Anyway, Vx is 0. Just I wrote it to see complete the loop equation. Nothing else, right? Anyway, Vx is 0. So II into R2 plus R4 is equal to Vi. So Ri is equal to Vi by II. It is simply R2 plus R4. Okay, that's it. Like this, we can do this problem. It's also a simple one. It looks like that, but there is nothing to worry. Yes. See this. An op-amp shown in the figure is ideal. The input impedance Vi by In is given by. Okay. See, whatever In is coming like this, the entire In has to go this way only. Okay. Then what about I input? It is V input here, V input minus V output by Z. But we know we should find V output like what we did in the last part 1 problem. So V output, how to write V output? Once you know voltage at the non-inverting terminal, anyway due to virtual short, V plus is equal to V minus is equal to V input. And if you take the node equation here, what do you get? V output is equal to 1 plus R1 by R2 into V input. Is it not so? Okay, we know that. Then let us substitute in that equation. So II is equal to I input is equal to V in minus V output is 1 plus R1 by R2 into V input by Z. So what do we get here? It is minus R1 by R2 into V input by Z. Then Ri, it is equal to V input by I input. It is minus Z into R2 by R1. That's it. And you may be getting a doubt like why this negative sign. The reality is, you look at the output voltage. It is 1 plus R1 by R2 into V input. So here V input and V output is greater than input. But you are assuming the current from lower potential to higher potential. V into V output. Obviously, In should be negative. V input may be positive. But as I input is negative, V input by I input, the result should be negative. You cannot get positive value. It's as simple as that. Okay. Output is greater than input. That's why you are getting I input as negative. So lower potential to higher potential, the current should be negative. Okay. That's it. So what you can write here, final answer, minus Z into this resistor by this resistor. Okay. Next. Same problem, data is given. Right, the input resistance Rn is equal to Vx by Ix of the circuit shown in figure is. Okay. How do we find it? Again, directly I am writing what I can write, this resistor. So R input is equal to, this is like your Z, means minus 1 mega into this resistor, that is 10k, means 10 power 4 by this resistor, it is 100k, means 10 power 5. So minus 100k you can see. Option B is correct. Directly I am writing the value. Okay. Next. The following circuit has R is equal to 1 kilo ohm, 10 kilo ohm, C is equal to 10 microfarad. The input voltage is a sinusoidal at 50 Hz with an RMS value of 10 volts. Under ideal conditions, the current from the source is, okay. They are asking us to find the current. Anyway, we have found the value of Vs by Is. That value is known to us. Is it not so? So we know Vs by Is is equal to minus this resistance, that is 10k, into this impedance, that is 1 by Cs divided by this resistor. Directly I am writing. Okay, I need not again calculate these things. It is minus 1 by Cs. Then what they are asking? Is. Is is equal to minus Vs into Cs. Okay. And what about the RMS value? RMS value of this current is equal to minus, right? What is Vs here? It is given as 10 volts, right? Minus 10 into C. It is R, I can write minus Vs into C into S is j omega R j 2 pi F. Then let me substitute the values. C, it is a 10 microfarad into J into 2 pi F is 50. Okay. So how much do you get? Minus J into 10 pi milliamperes. You just check it. Okay. 10 power minus 4. 10 power minus 4 can be written like 0.01. 0.0. Okay. Anyway, it's minus 10 pi. Right, you can just see this. So RMS value only. The negative sign indicates that the current is lagging behind the voltage. So it is a 10 pi milliamperes lagging by 90 degrees. So 10 pi milliamperes lagging by 10 milliamperes. Okay. 10 power minus 2 amperes. 10 power minus 2 amperes can be written like 10 milliampere. Correct. Okay. So very simple. An op-amp shown in figure is ideal. The op-amp shown in figure is ideal. The input impedance seen from the current source is given by. Okay. So what is R equivalent? Actually Vx by Is. What is Vx? What is the voltage at this point with respect to ground? That is just nothing but V output. So we need to find V output by Is. How do we find it? See, what about this current? It should be Is. Okay, let me assume this voltage as some VA. Then, okay, this current is some I2 and this current is I2 plus Is. Okay, then how to find V output by Is? We need to check it. First point here, V output minus VA is equal to I2 into R2. Also, V output minus VA is equal to Is into R1. We can write. So what about I2 then? It is R1 by R2 into Is. Okay, done. Then what about our V output? V output is equal to voltage at this point with respect to ground. That is I2 into R2 plus I2 plus Is into R3. Okay. And instead of I2 into R2, I can write Is into R1 also. Nothing to worry about it. We can write even that also. Because here only we have I2 into R2 is equal to Is into R1. Is into R1 plus what about I2? It is R1 by R2 into Is plus Is multiplied with R3. Now, if I take Is common, it is R1 plus R1 by R2 plus 1 into R3. Okay. So, what about the Ri value? It is V output by Is. It is equal to R1 plus, I can write R3 plus R1 R3 by R2. Or we can leave it like this, R1 plus 1 plus R1 plus R1 by R2 into R3. Anything we can write like this. Okay. This is the idea. Like this, we can find the equivalent resistance. Next, determine the input impedance of the circuit of figure and investigate if it can be inductive. Okay, how do we do this? Again, ZS they are asking if I connect here some Vs and this current is Is. Vs by Is gives us Zs. Is, again here there is a node, some current is possible like this, it is I2, and some current is possible like this, I1. Okay, so what about I1? I1 is equal to Vs by 1 by Cs plus R2. That is Vs into Cs by 1 plus SR2C. Keep it aside. And I2 is equal to Vs minus, let me take this as V output by R1. But what is V output in terms of Vs? See, this is V output means this is V output and this is also V output. And hence V output is equal to Vs, voltage division rule I can write, V output is equal to Vs into R2 by 1 by Cs plus R2. It is equal to Vs into SR2C by 1 plus SR2C. Okay. Then I2, which implies I2 is equal to Vs minus V output means Vs into SR2C by 1 plus SR2C whole thing divided by R1. Then what do we get? It is Vs by 1 plus SR2C multiplied with 1 by R1. Okay, we can write like this. I1 and I2 are known to us. Then I is equal to I1 plus I2, or Is is equal to I1 plus I2. What is I1? Vs into Cs by 1 plus SR2C plus I2 is Vs by 1 plus SR2C multiplied with 1 by R1. Okay. Then let us take Vs by 1 plus SR2C common, then Cs plus 1 by R1. Then it is further written like Vs into 1 plus SR1C by R1. Okay, and anyway here divided by 1 plus SR2C. So Zs, or it is equal to Vs by Is is equal to R1 into 1 plus SR2C by 1 plus SR1 into C. That's it. This is our answer. You see, I'm not at all changing my procedure. Right? I'm just calculating I1 and I2. I'm writing I1 in terms of Vs and I2 in terms of Vs and total Is in terms of Vs. So Vs by Is gives us the impedance. That's it. Next, the op-amps shown in figure are ideal. The input impedance seen from the source is given by. What is the input impedance seen by the source? Okay. See, is there any current that is possible here? No. So definitely if I assume this current as Is, entire Is will be coming up to this node. I can say. Okay. Then let me take this is amplifier 1 and this is amplifier 2. So this voltage is Vs, means this is also Vs. Due to virtual short, this is also Vs. Due to virtual short, this is also Vs, means this is Vs. Done. First we applied virtual short and wherever Vs is going we have seen. Next, let me take this voltage as VO1, means this is VO1, and output of this op amp it is VO2. Okay. Okay. Then what is our Is? Vs minus VO2 by 1 by Cs, where C is equal to 1 farad. That's the idea. Now I need to write VO2 in terms of Vs. How to get VO2? For finding VO2, we should know what is VO1. How to get VO1? See, let me take this as node A. This voltage is 0, this voltage is Vs. Then by taking this node equation, we can find this voltage. So KCL at node A, Vs minus 0 by capacitor values are same 1 farad. So 1 by Cs, I can write instead of C, I am writing 1. So S plus Vs minus VO1 by 2 is equal to 0. Okay. Then Vs into S plus 1 by 2 is equal to VO1 by 2. So what is VO1? It is 1 plus 2S into Vs. Okay, VO1 we have got by taking this node equation. Next, I told you don't take any node equation here, meaningless. Okay, because we do not know this current. If whenever you want this current, then only I can take this node equation. But I am not interested in this current. I am interested in the node voltage, but not the current. Okay. Next, here VO1 is known and Vs is known. VO2 is unknown. Let me take this as node B. If I apply KCL at node B, then this voltage is known. Then we can find the unknown voltage VO2. Okay. So KCL at node B, then it is Vs minus VO1 by 1 plus Vs minus VO2 by 2 is equal to 0. Okay. So Vs is known, VO1 is known. Automatically we can write VO2. So VO2 by 2 is equal to Vs plus Vs by 2. That is 3Vs by 2 minus VO1. But what is VO1, friends? It is 1 plus 2s into Vs. So 3Vs by 2 minus 1 plus 2s into Vs. Okay. Then 3 by 2 minus 1, it is, okay, 1 by 2 Vs. If you observe this, it is Vs by 2 minus 2s into Vs, that is VO2 by 2. So what is VO2 then? VO2 is equal to Vs minus 4s into Vs. Okay. We can write VO2 like this. So now what about Is? Is is equal to Vs minus VO2 by 1 by S, because C value is 1. So Vs minus VO2 is Vs minus 4S into Vs whole thing multiplied with S. So what do you get? It is 4S square into Vs. So Zi is equal to Vs by Is. It is 1 by 4S square. Okay, that's it. This is how we can do this problem. See, it looks like complex. Nothing is there. I'm doing simply, I have not changed my procedure also. Okay, I'm writing Is in terms of Vs. Finally, I'm deriving what is Vs by Is. And nodal analysis also. That procedure I have not disturbed. Apply virtual short everywhere. Later, you don't never ever take node equations at the output terminals, friends. Okay, you won't get the answers because we do not know this current. If they ask the current, then only I can take the node equation. This is what I told in my previous lectures as well. Next question. The circuit shown in the circuit given uses an ideal op-amp. The current I in microamperes drawn from the source Vs is up to 2 decimal places. In microamperes they are asking. Okay. So VSIS. Actually, instead of asking Vs by I, they are asking only I. Doesn't matter. So Let me take this current as I2 and this current as I1. Okay, and this voltage is V1 and this is V output. V out or V output, anything you can write. Okay, so what is I1? Due to virtual short, it is 0 volts. Due to virtual short, it is 0 volts. So I1 is equal to Vs, that is 1 volt. Directly I am writing 1 minus 0 by 10k, it is 0.1 milliampere. Okay, I1 we have got. And I2 is equal to 1 volt minus V2 by 10.1 kilo ohm. Okay, means I need to find V2. How to find V2? First V1, it is equal to minus 20k by 10k into 1 volt, that is minus 2 volts. 20k by 10k into 1. And V2 is equal to minus 20k by 20k into V1. How much do you get? If V1 is minus 2, anyway, it is plus 2 volts. We got V2 also. Then I2 is equal to I2 1 minus 2 by 10.1 into 10 power minus 3. 1 by 10.1, if you calculate it, is 0.099 milliamperes. Okay, 1 by 10 means 0.1. Instead of 0.1, you will get 0.099 milliampere with negative sign. Yes. Then what about I? I is equal to I1 plus I2. It is equal to I1 0.1 milliampere minus 0.099 milliamperes. It is 1 microampere. Directly I am writing because they asked in microamperes. That's it. Okay. In the circuit given below, the op-amp is ideal. The input Vx is a sinusoidal. To ensure Vx is equal to Vy, the value of Cn in picofarads is, what is the value of this capacitor? Okay, how do we find this? See, if I take this node equation, right, what we can write, let me take it as node A, KCL at node A. Vy minus Vx by 10k, 1k, sorry, plus Vy by 1 by, let me take this capacitor as a C, Cs or Vs minus 0, doesn't matter, plus Vy minus V output by 1 by Cn into S is equal to 0. Okay. Then anyway Vx is equal to Vy. To ensure Vx is equal to Vy means we can remove that. Then Vy into Cs plus Cns is equal to V output into Cns. Okay, we can write like this. And further, anyway, S I can calculate, or C plus Cn into Vy is equal to Cn into V output. So we need to find V output in terms of Vy. How to write V output? Anyway, due to virtual short, it is also Vy. So what is V output? V output is equal to 1 plus 10k by 1k into Vy. That is 11 into Vy. So C plus Cn into Vy is equal to Cn into 11 times Vy. So here Vy cancel. So C plus Cn is equal to 11 Cn. Or what we want? Cn we want. Cn is equal to C by 10. What is the C here? It is 1 nanofarad. So in picofarads means it is 100 picofarad. That's it. Okay. Like this we can do this problem. Assuming ideal op-amp, the RMS voltage in millivolts in the output only due to the 230 volts 50 hertz interference is up to 1 decimal place. Okay, here the circuit has one AC source and one DC source. They are asking to find the output only due to the AC source. So what we do? Superposition. While studying the effect of AC, we will make the DC source 0. So if the DC source is 0, how does the circuit change? See here, minus plus. Anyway, the feedback resistor, it is 50K. Next, I am directly writing here this 3 picofarad is present, and that is going to our AC source. Let me write this as Vs. Next, from the inverting terminal to, right, as DC source is 0, once it is 0, it should go to ground. Means this 10K is going to ground, and from the source, one more 1.3 picofarads, that is also going to ground. Okay, and one more thing, from source to output, we have source to output 0.3 picofarads. This is how the circuit is once you remove the DC source. Now what we can do further, this does not play any role, and due to virtual short it is 0 volts. This 10K also does not play any role. What is our equivalent circuit further? We are left with 10K, 3 picofarad and 0.3 picofarad. Let me write it in the next page. 10K, 3 picofarad, 0.3 picofarad, and it is Vs. Okay, 0.3 and 3 picofarad, correct. Now what is the output? Just we can take this one, virtual short, it is 0 volts, and the node equation minus this one 10K by 1 by Cs into Vs. We are well aware. Into Vs, that is minus 10 power 4 into C into, instead of S I am writing J 2 pi F into Vs. Okay, so what is the value of the capacitor here? It is C. Let me write it, and it is C1. Let it be. I need not worry about the value of C1. So it is 3 picofarad minus 10 power 4 into 3 into 10 power minus 12 into J 2 pi F is 50. Vs, its RMS value is given as 230. Okay, and if you further calculate it, we get its value to be RMS value, no? So as it is RMS value, we output RMS I am writing, so I should take the magnitude, and it comes to be around 10.8 millivolts. Directly I am writing here. You can just have a look at the calculations. Okay, that's it. RMS means we should take the magnitude. We are well aware of it. That's it. So, okay, next topic is active filters. That's very, very interesting topic. We'll see that later. So, new topic.